Hi, greetings of the day. Welcome to my channel AI. My name is Vidya. In this session, we are going to discuss an example of time complexity computation that maps to O of n. Consider a use case where we have an array of size n where element e is expected to be searched. The scan starts such that if element e is found, then it returns true, it continues to search until the end of the array on n elements. If the element E is not found, even on a complete search, then the algorithm returns false. Now let's go and implement this. To begin with, as usual, we have package main for the Go program. We are going to use a bunch of printf statements and therefore we are going to import fmt. And then we begin with the function main as an entry point for this program. We also call upon function myfunc where the search happens. Which takes n as an input and search element E, thereby returning bool true or false. Okay. So we go ahead and declare the array, initialize it. Let's consider this an int array. 4, 7, 3, 11, 23, 53, 42, 12, and 78. So these are the bunch of elements that we are going to have. Now we begin with search. For I equal to 0, I less than n, I plus plus, we search till end of the array. If array of I equal to element, then we return true. Else, we hit this line and we return false. So we are done with the search. Go ahead and call search in the main function. The return code will be bool return code equal to my function. I would search for how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. I'll search for 12. So the expectation is it has to return true. So if return code equal to true, fmt.println element found. Else fmt.println element not found. We go ahead and save this. Go run. Should get the result. Element found. Element is found. Good. The program is working. Now the time complexity for computation or search that's involved across this array is n, meaning that the requirement is it walks through n elements, all from index 0 until end of the size of the array. And in worst case, if 12 was found here, it would be looping about 8 times, and if 12 was found here, it would be looping about 9 times. So the maximum number of times that takes for the loop to happen is declared by what is known as O of n complexity. Now we introduce a small twist to the previous problem by searching for the element E in two arrays instead of one. So I'll just make this as array 1, and then we'll have another array over here which will be array 2. There could be a bunch of new elements, 8, 71, 13, 311, 3, 22, 52, 99, and 108. So we have two arrays of same size n. Now if it's found across array 1, we return true. We perform the same thing across array 2 as well. Basically we perform search twice. This is array 1, this is array 2. So if found, we return here, otherwise we hop here. Again, if we have found the element, we return. If found in neither of these arrays, then we return false. So now I'm going to provide 13 or 311. Let me go ahead and give 311. So array size is 9 on array 1 and array 2. I'll attempt to search 311. So it should be found in the second array, essentially meaning that we have finished one set of iteration over here, and then we are hopping into the second set of iteration, and we find the element in this second block. So the time complexity will be n times over here, and then somewhere nearing n times here. So it should be 2n. Let me go ahead, save this. Element 311 is found, and the complexity here will be O of 2n. We have observed that the loop runs two independent circles or iterations, each of O of n running time complexity. Now the time complexity of the above algorithm will be 2 times O of n. Considering the property of asymptotic analysis by suppressing the constant, we would simply say the time complexity is O of n. Thanks for watching.